You ever stop and think about something simple, like a dog, or something complex, like justice, and wonder, where did that idea actually come from? I mean, how does all the chaotic noise from our senses get turned into a single, clear thought? Well, that's exactly what we're diving into today, the incredible mystery of how our brains build ideas, literally from scratch. So here's our game plan. First, we'll pin down what a concept even is. Then, we'll tackle what's known as the grounding problem, which is a really big deal in cognitive science. From there, we'll see how the brain actually forges these concepts from raw sensation, how it organizes them, and then we'll get to the big one, why this all matters so much, especially now, in the age of AI.
I mean, really think about this question. It's kind of wild, isn't it? That all the sights, sounds, and feelings flooding into your brain can be distilled into something clean, simple, and communicable. It honestly feels like magic. But what we're going to see is that it's not magic at all. It's this amazing, intricate dance of statistics, prediction, and organization.
All right, so first things first. Before we can talk about building with blocks, we need to know what the blocks are made of. What exactly is a concept?
Just think about the word apple. Boom! Your mind doesn't just see letters. It pulls up a whole bundle of information, right? Red or green, roundish, sweet, crunchy, grows on trees. Concepts are the Lego bricks of our minds. We use them for everything, from deciding what to eat to figuring out complex problems, and we do it without even thinking about it.
But this brings us to a huge, kinda awkward problem that for the longest time, a lot of people just ignored. Cognitive science got really good at explaining how we combine concepts, but they sort of skipped a step. They never really explained where the most basic features, like red or round, even come from.
And this was a massive, massive assumption. It's like trying to explain how a house is built by saying, well, you start with a pile of bricks. But wait a minute, where'd the bricks come from? How was the clay dug up and fired? That's the real question here. How does the brain create this fundamental vocabulary of red, round, and sweet just from looking at the world?
And this right here shows the huge shift in thinking that happened. The old way, the container metaphor, saw the mind as a computer locked away in your skull. It gets some input, does some processing, and then sends an order out. Sense, plan, act, all neat and separate. But the grounded cognition view says, nope, that's not how it works at all. Thinking isn't a separate thing happening in your head, it's an interactive dance between your brain, your body, and the world around you. Sensing and acting are all tangled up together.
And that brings us to the answer. Grounded concept formation. This is the big idea. It says our concepts aren't just abstract computer code. They are grounded. You can trace them all the way back to the raw, messy data coming from your eyes, your ears, your hands. It solves that giant assumption we were just talking about.
Okay, so if our concepts are born from our senses, how in the world does the brain actually do that? How does it take this absolute chaos of sensory input and forge a stable, reliable set of features out of it?
You gotta love this analogy. Your brain isn't just passively soaking up information like a sponge. It's an active prediction machine. It's constantly making its best guess, running statistical inferences about what's actually causing the signals it's receiving. It's trying to find the patterns in the noise. And a really popular way of thinking about this is the predictive coding loop. It's so simple and so powerful. Step 1, your brain predicts what it's about to see or hear. Step 2, your senses deliver the actual real-world data. Step 3, the brain compares its prediction to reality. If there's a difference, a prediction error, it updates its internal map of the world. It's this endless loop of predict, sense, and correct that allows us to learn and navigate reality. So one way it does this is through pure optimization. It turns out that the wiring in our visual cortex is almost perfectly tuned to pick out the most common statistical patterns in nature, things like edges, lines, and curves. It learns this on its own, driven by one simple goal: minimize that prediction error. The brain fundamentally does not like to be surprised.
The other major trick up its sleeve is finding what doesn't change. Just think about your coffee mug. You see it from the side, from the top, in the dark, in bright light. The raw data hitting your eyeballs is completely different every single time. And yet, you instantly know, that's my mug. Your brain is a master at ignoring all the irrelevant changes and locking onto the core invariant features. This is how it takes a flood of data and boils it down to one simple, stable idea: mug. So, pretty amazing, right? The brain uses stats and this idea of invariance to create a whole vocabulary of features. But, a list of words isn't a story. How does the brain organize these features into the incredibly rich, complex web of ideas we use every second of every day?
Okay, this is where my mind gets a little blown. One of the coolest theories out there comes from Peter Gardenfors, and it's called conceptual spaces. He basically said, what if we think about our concepts geometrically? Imagine a giant, multidimensional map. On this map, concepts are like regions. Things that are similar, like red and orange, are right next to each other. Things that are totally different, like red and salty, are miles apart.
Yep, this quote just nails it. Meaning isn't some dusty definition in a dictionary. It has a shape, a location. This geometry of thought is what lets our brains so easily grasp relationships, similarities, and differences between things. It's incredibly intuitive.
And look, the brain has more than one trick in its back. It uses all kinds of strategies. We build categories around prototypes. Like, when you think of bird, you probably picture a robin, not an ostrich. We're also amazing at generalizing from just one or two examples. And critically, even our most abstract ideas can act like an index, allowing our brain to trace their meaning all the way back down to the original sensory experiences that built them.
So, we've gone pretty deep into the nuts and bolts of how we think. But let's pull back up. So what? Why does any of this matter? What are the real-world consequences of our thoughts being grounded?
At the end of the day, here's the bottom line. Our intelligence is not like a piece of software running on hardware. It's embodied. Our entire ability to think and understand is fundamentally shaped by the fact that we have bodies that move through and interact with a real physical world. Our ideas aren't just abstract symbols. They're echoes of action and sensation.
And that leaves us with a really, really big question for the world we live in right now. We are building these unbelievable AIs that can manipulate language and data better than any human ever could. But if our understanding is fundamentally tied to having a body, to feeling the sun, or lifting a rock, what does that mean for an AI that has never experienced anything at all? What can it ever really, truly understand? Something to chew on.